In this video, I'm going to show you how to use the batch feature of Hobbits to execute complicated sequences of plugin actions in a repeatable way. We'll start with a simple example of an invert operation. We'll load up the Hobbits binary. We'll perform an invert on it using the take-skip operator. And then with the output selected, we go to File, Save Batch, give the batch a name. And then if we want to do that invert action on a different file, we simply open the file, select it, and then apply the batch. And then we see the I star or invert all bits take skip operation has been applied to the new bit file that we opened. So most of the time batches are useful if you're doing something a little bit more complicated than a single plugin action. So next we'll look at using kaitai struct to analyze a binary and then using the extractor to extract a specific section out of that binary. So we'll open up a TTF file. We'll use kaitai struct to analyze that TTF format. We see that we get a few different sections, these directory table sections parsed out by kaitai. Then we'll go to the extractor. We'll select one of the directory tables. We'll extract the section. And then we get this directory table. So we can save the kaitai struct analysis operation and the extraction in a single batch by selecting that output, file, save batch. We're saving the actions before the selected container. So we're selecting the last container in the sequence and then saving all of the actions that led up to that container. Give it a name. And then if we open up, like we'll remove all these. If we open up a TTF file and then we apply that batch, we see it did the same kaitai struct analysis and then the same extraction of the directory table. Another thing we can do with batches is save the way the data gets imported. So for example, if we import some bits from a hex string, and then we perform some kind of take skip operation on it. And then we save that batch. We can also save the import actions when we create the batch. And then when we run that batch, instead of it happening to the container that's currently selected, it's going to prompt us for a hex string input. So we can give it a different hex string input this time. And then it imports the hex string and then does the same take skip operation. You can also take that a step further and include the information in the hex string import or any type of importer. So save the state of the importer as well as which importer was used. So if we save that one and we save the action state as well as the import action, Then when we run that batch, it just runs the importer with the same state that we had before. So just to clearly show that, get rid of all these. When we run that batch now, it just creates it. That could be useful if you have a specific importer. So if you're doing a specific TCP import from GNU Radio, a specific HTTP data import, if you're importing a static type of some static bits to operate with other bits, or if you're importing from the same file to then operate or interleave with other bits, you can do that. So let's do that. Let's interleave that with a file and then save that. So open that TTF file we were working on earlier. We'll invert that. And then we'll interleave these in a byte-wise fashion. So we're going to take that output and that output. And then we get this weird interleave data. And then we can save that batch. And then when we apply that batch, it just does everything. The other thing worth noting is when you have parallel operations like that, it usually is able to optimize and run both of them at the same time on different threads. That wasn't something that the old template system was able to do. Just another quick example to show the multi-threaded operator execution in the batches. This one just generates some data and then interleaves it. We can see in the progress bars that things are being run at the same time. So that's it for now. If you have any questions, please reach out via Discord or GitHub.